So next problem. In the network shown in figure, the switch is changed from position number 1 to 2 and steady state condition is having reached before switching. Before switching only already steady state is reached in capacitor because it is connected to the one. In this one actually capacitor is there. This capacitor is already reached steady state and at t is equal to 0 the switch is changed from 1 to 2. Find values of I di by dt d square I by dt square at t is equal to 0 plus. That is just after switching you have to find out I value, di by dt value and d square I by dt square value. So I already told, okay, switching is, suppose this is t is the switching point at 0, that instant is called as 0 plus. So from t is equal to minus infinity to 0 minus, this portion is before switching. This is exactly at this portion it is just after switching, and this is after switching we call it as t greater than 0. So these are the three important points. Now let us find out solution. It is already given that with position number 1, that means here the switch is changed from position number 1 to this. So the actual circuit now, this 10 ohm is not connected to the 30 volts. The only one end of 10 ohm is connected to here. The second end of 10, that is here, it is not connected to the circuit. This is just hanging, so it is not considered. So actually original circuit is this. So before switching we have 30 volts, okay, then this is 1 and this is 20 and here capacitor was there and this is 10 ohm, other end is not connected now, so just you can ignore it. So actually this circuit is this, okay, and it is given that steady state is already reached in this position. That means for long time this position was here. So already steady state is, we know that initial condition at just after switching the capacitor acts as, at initial condition capacitor acts as short circuit. In the final condition capacitor acts as open circuit because the capacitor will reach the maximum voltage and it acts as open circuit. So just recall the table here. Capacitor at the instance it acts as a short circuit, but in the steady state means for long time if you keep it on connected, capacitor will charge to maximum value and no current will flow. It acts as a open circuit. So I already explained in the last problem. If any, okay, capacitor acts as open circuit. Now this is in the position number 1. The switch is in the position number 1. Okay, the switch is in the position number 1. Now capacitor acts as open circuit. Capacitor acts as open circuit and before switching, this is called as t before switching. Okay, still switching is not checked. Switching means from 1 to 2. So before that you have to consider this as t minus. Okay, so before switching is t minus. So in that position we have circuit 30 volts, then 20 ohms, and capacitor acts as open circuit. Since its capacitor is already charged to 30 volts. Okay, capacitor already reached to 30 volts. Okay, so now what is the I minus you have to find out. So since capacitor is acting as an open circuit, I of 0 minus is 0 amps because it is an open circuit, and voltage across capacitor. Capacitor reaches to maximum 30 volts. After that only steady state will reach and it acts as an open circuit. And if you keep multimeter positive here, multimeter negative here, now this is at this potential, this is at here, so it is 30 volts only. Voltage across capacitor is same as 30 volts. And already you can also indirectly can tell that capacitor will fully charge to 30 volts. So same 30 volts will appear here. Okay. And if the capacitor, that is nothing but your battery fully charged, Again, if I remove and change the switch position, still that capacitor will have that voltage value. Okay, VC of 0 minus is same as VC of 0 minus. Just after switching, its voltage will not become immediately 0. It will take some time to discharge. So VC of 0 minus is same as VC of 0 plus. Now let us consider. So we calculated what I of 0 minus is 0. VC of 0 minus is 30 volts. Now let us go to the second point. Switch is closed at t is equal to 0. Okay, at t is equal to 0 plus, that is just after switching. Just after switching. This is just after switching. What happens? It changes from 1 to 2. No, so please observe here. The circuit is going to change from 1 to 2. If I go to 1 to 2 here, this is now the second end of 30 volts. Positive end of 30 volts is 1. This is, it is not connected. So this becomes 30 volts becomes, you can like this. You can consider here 30 volts, and this end is not connected. So you can ignore this. Okay. This will be there, but only one end is not sufficient. If both are connected to the circuit, then only you can consider this 30 volts. Since second end, that point, this terminal 1 now, this end is not connected to the circuit, this 30 volts can be ignored. Now actual circuit is only this much. Okay, only this much you have to consider. Now what happens if this is now considered at t is equal to 0 means just after switching. Just after switching from 1 to 2, this is a switch number. Switch is changed from 1 to 2. This earlier it was here, now it is changed to here. Now new circuit is this. This 30 volt is not connected because other end of this positive terminal of battery is not at all connected to the circuit. So this is just hanging. So this is not considered. Now let us write the expression for I of t. This is 20 ohms, and this is a 10 ohm in the circuit. You can see here 10 ohm. This is 20, and capacitor if initially charged, it is replaced by, if capacitor is there, if capacitor is initially charged to 30 volts, if initially capacitor voltage is charged to 30 volts, now instead of capacitor short circuit, it should be replaced by voltage source followed by short circuit. Okay, voltage source you have to write. So it is 30 volts, and you can consider as followed by short circuit, or you can just tell that it is 30 volts. Polarity plus minus, because the charging of capacitor is plus here minus here. When the current flows here, plus is here, minus here is here. So we can consider it as a voltage source of plus minus. Now I have to get expression for I. I is equal to voltage divided by sum of resistance. Voltage is 30 and resistance is also 10, 20 and 10 is in series 30. So it is 30 volts by 30 ohms. It is 1 amp. So it is given as minus 1 amp. Why means always current flows from positive to negative. So like this. Or you can write KVL for this. So I can write I of t in the circuit given. See the circuit, original circuit given I of t is clockwise. So plus minus that given. This is plus to minus, and this is also plus to minus. I will write from here plus to minus from 20, from 10 ohm I will write plus 10 I of t, 20 I of t. Again this is also plus starting, plus 30 is equal to 0, or 30 I of t is equal to minus 30. I of t is equal to minus 30 by 30 is equal to minus 1. So I of 0 plus, substitute t is equal to 0 plus, substitute t is equal to 0 plus. So I of 0 plus is minus 1 amp. It is given clockwise, but actually plus is here. Actual current is flows opposite. Actual current flows 1 amp opposite. Since in the original circuit I of t given as clockwise, we have to write minus 1 amp. Okay, next I of plus is over. Next we have to find out di by dt. For t greater than 0, for t greater than 0, we have to write KVL. Apply KVL. If I apply KVL, plus minus plus minus plus minus with position number 2. So 30 volts will not come into picture, only for this circuit. Okay, after switching only for t greater than 0, we have to apply KVL. So it is 20, or I will start from 10, 10 I of t plus 20 I of t plus what is the voltage of capacitor is 1 by C integral I of t dt is equal to 0. So 20 plus 10 is 30 I of t and C is 1 micro. 1 by C, C is 1 micro. 1 micro if you bring it to numerator, 1 micro means, okay, 1 micro means 10 power minus 6. Micro means 10 power minus 6. 1 by 10 by 1 by C means 1 by 10 power 6. If you bring it to numerator, it becomes 10 power plus 6. Okay, this is 1 by C. 1 by C is 10 power 6 into I, integral of I of t, and that is option. If you want, you can write that capacitor voltage 30 volts is there, no? You can write 30 volts in parallel in series with capacitor. Anyway, once you differentiate, this term will get off. Okay, this is optional. If you don't write also, it will work. Okay, it's a constant anyway. It is a constant. So they are written 40 greater than 0 capacitor initial voltage plus this charging voltage. Okay, they have written 40 greater than 0 capacitor voltage, and this is optional anyway. Once you differentiate, this will go. This will go because we have to find out di by dt. Since it is a capacitor, we have integration term. In order to get di by dt, we have to differentiate this. So now, if I differentiate, apply 30 I of t 10 to the power 6 integral of I of t plus that is equal to 0. Now we have to differentiate this equation with respect to t. 30 di by dt 10 power 6 integral and differential will get cancelled, and integration of constant is 0. So that's why I told without this also you can consider equation. And if you substitute, what is the di by dt value you have to find out. I of 0 plus we calculated. I of 0 plus is minus 1. I of 0 plus is minus 1. So 30 di by dt, this is I of 0 plus is minus 1. So minus 1 into 10 is uh, minus 10 power 6. If you bring it to right side, it will become plus 10 power 6. Okay, it become plus 10 power 6. Here it is there, plus 10 power 6, and di by dt is equal to plus 10 power 6 divided by 30. So this answer is correct. Or you can simplify 10 power 6 multiplied by, you can do like this also. If you bring 10 power 6, 10 power 6 divided by 30, it is 33.33 10 power 3, or you can write 0.03 10 power 6. Both are correct. You can write like this, ampere per second. Similarly, I have to find out d square I by dt square. So this equation number 1, we have to differentiate once again. Or equation number 2, anyone you can differentiate. No, equation number 1 already differentiated. We got I of t. Now in order to get d square I by dt, di by dt term must be differentiate once again. So you have to differentiate this equation number 2. Equation number 2, if you differentiate 30 d square I by dt square 10 power 6 di by dt is equal to 0, and d square I by dt square is equal to this. If you bring it to right side, it becomes 10 power 6. So this plus term becomes minus. This plus term, if you bring it to right side, it becomes minus 10 power 6 di by dt, and you have to divide 30 di by dt is this term. So di by dt is you have to divide by 30. So it is 10 power 6 by 30 and the value of di by dt. So now if I put d square by dt square at t is equal to 0 plus, we have 10 power 6 di by dt value at 0 plus is 10 power 6 by 30. So 10 power 6 plus 10 power 6 is 10 power 12. 30 into 30 is 900. Okay, I can keep like this, or this 2 zeros is cancelled with 2 zeros here. So we left with 10 power 0. Sorry, 10 power 10. minus 10 power 10 by 9. Okay, so let us check the answer in the textbook also. We have one textbook here. It's 0.33 10 power 5, the same as whatever answer we had given, and it is 1 by 1 minute. It is same as this answer, so it is also 10 by, I think 1 point minus 1.1. How it means? So take a calculator and divide 10 by 9. It is 1.1. 1.1 into, okay, 1.1 into 10 power 9. 1 by 9 means 1 point minus 1.1. You can divide 10 by 9. Okay, 10 by 9 into 10 power 9. 10 by 9 into 10 power 9. So that will give you 1.1 10 power 9. Or you can keep this answer, or you can keep previous answer. Anyone is correct.